So in this question, we have a marble being thrown straight up into the air, like so, releasing to short height above the ground and catching it at that same height. So the person is standing there, they kind of throw it, and they catch it at the same height. Air resistance negligible. Position versus time is correct for the motion of the marble as it goes up and comes down. So let's first see if we can sketch this out. So the position initially, if we set this equal to 0, it would start here. And we know the position is going to go up to some maximum height, and it's going to come back down to the final height. So the question is how is it shaped? We know in the beginning it's going to be at this height, and it's going to return to that height later. We know it's going to reach some maximum height. So is it going to be straight line? Is it going to be like this? Or will it be like this on the way up? Now, if we do our RGA part of this, we can read position time. The gradient's delta x over delta t, which is the velocity. Now, we know if the slope is the velocity should be decreasing. So if we look at this one, the slope is constant, so that's out. This one shows the slope increasing, so that one's out. This one shows the slope decreasing. So what we're looking for is a curve that initially is going to do this, and of course we expect the symmetry, it'll come back down. So we're looking something like that is what we expect. So you notice this first one has this and this and this element. This one has this and this and this and this element. Of course, it's not the straight one. And we know we already ruled that one out. And we ruled that one out because of the symmetry, and lastly, not symmetrical. So notice by doing that work of thinking through that there will be these common heights, a maximum height, and that it will not be linear, allowed us to answer that question easily up front. So we got a ball thrown straight up in the air when it reaches its highest point. Well, we know the velocity is 0. It's a z max, and we know g is the same everywhere. Let's see what they're looking for. It is in equilibrium. That means it's in balance. Now, technically, this isn't a question that belongs in kinematics, if this is a possible answer. In balance means the forces are balanced. And if the forces are balanced, there's no acceleration. So that can't possibly be the case. Since there is acceleration, it's not balanced. It's not in equilibrium. Has 0 acceleration is false. Has maximum momentum. We don't know what that is yet. Again, why this shouldn't be in this topic. Has maximum kinetic energy. Maximum kinetic energy, you should know from middle school, it's related to the speed. Now, if it's at the top, it's going to have the least. If it's at the top, it's going to have the least amount of speed and the least kinetic energy. So it's not in equilibrium, doesn't have acceleration, it's not the highest kinetic energy, and we don't know what momentum is. It turns out it doesn't have the max momentum, it's actually the least momentum as well. Momentum is also related to speed. So you would come right by not being able to answer this one, but the best answer is E, none of the above.